All right, I'm going to go ahead and go through the Chapter 7 Quiz 2 review as I just posted about an hour ago on Google Classroom so that you guys can kind of hear maybe some key details and review some key details. But I want to stress the importance of using your notes. When you go through my lecture videos, you need to make sure you're taking notes purposefully so that you can look back at these skills that I'm teaching. Okay, so on number 1, I'm diving right in. It says, what is the period of y equals sine 2 pi x? How do you know? Okay, well, the first thing we need to review is general form of a sine function. Y equals a times the sine of bx plus c and then plus d. Okay, now we may have used different letters for these a few lessons ago, but as a quick review, A deals with the amplitude, the height of the peaks and valleys, and the reflection over the midline. C deals with the horizontal shift. If C is positive, it's going to shift left. If C is negative, it's going to shift right. D deals with the vertical shift. If it's positive, it's going to go up. If it's negative, it's going to go down. And then what question 1 is asking about is this letter B. Okay, now B is not the period. B represents the number of cycles that are going to occur for the wave in the span of 2 pi. Okay, now this is very weird because we see 2 pi occur in this equation. Okay, well, what is 2 pi? A lot of times it's nice to multiply it out on your calculator and see, just to give you an idea, that 2 pi is approximately 6.28. So what does this mean? A little more than 6 cycles of the sine wave are going to occur in the span of 2 pi. Okay, so we can say about 6.28 cycles of sine will occur in 2 pi, but the big question that we need to answer is, what is the period? Okay, so if you look back in your notes, we specifically taught that the period is found by taking b divided by 2 pi. You have to take, sorry, my bad, reverse that, erase, 2 pi divided by b. What is the length of one cycle? That's what the period means. So if I go ahead and do this, I'm going to use my space down here. I'm going to take 2 pi, and what is my b? My b is 2 pi. So what's anything divided by itself? 1. So what is the length of one cycle in this case? It's 1. Okay, so the answer is simply 1, but what did you need to know? You needed to know a period. You take 2 pi over the value of b, which in this case, the value of b was 2 pi. All right, moving on. Okay, now we are going to talk about converting radians to degrees and degrees to radians. Okay, now when we see that we are converting radians to degrees, A, B, and D, we are going to take the value, in this case it's pi, and we're going to multiply it by the unit conversion, which there's 180 degrees in pi. That you could use 360 over 2 pi, but let's keep our numbers as small as possible. So when I take pi over 1 times 180 over pi, okay, you can always multiply straight across the top or do some kind of fraction buster type ideas, and we see that in this case our pi's are going to cancel out, so we get 180 degrees. On this second one, okay, we have 3 pi and we want to multiply it. You always multiply it by 180 degrees over pi. Okay, again, our pi's drop out. So we are doing 3 times 180, which is 540 degrees. is equivalent to 3 pi. Okay, while we're on a streak here, we're going to take pi over 4, and we're going to multiply it by 180 over pi. Now, pi over 4, yes, it's technically over 1, but in this case, you can just multiply still straight across the top and bottom. Okay, well, the pi's cancel out, so what I'm left with is 180 over 4, but you need to go ahead and do that division, which is 45 degrees. And most of you guys are at the point where you recognize immediately that pi over 4 is 45 degrees, and that's okay. Okay, so that would be one where I don't really expect you to necessarily show work if you've memorized your unit circle. All right, now we are going to look at degrees to radians. So when I'm starting with degrees, I'm going to multiply not by 180 over pi, but pi over 180. Okay, the same units need to be separated, one on the numerator, one in the denominator. Okay, so in this case, I'm really thinking about 30 over 180, and I'm just going to use my calculator to reduce the fraction. I'm going to do 30 divided by 180, math, enter, and I'm going to get 1/6. So I'm looking at this as 1/6 pi, but you're never going to write it that way. You're going to do 1 times pi, and then keep your denominator. So pi over 6. Again, this is one that I wouldn't expect to see work on from all of you, because you should start memorizing that pi over 6 is 30 degrees. Okay? But if you want to use the conversion, let's go on to E. We have 225 degrees. We're looking at pi over 180 to keep those degrees, one on the top, one on the bottom. So I'm going to take my calculator, do 225 divided by 180, math, enter, and I see that that's 5/4, so I'm catching on to the pattern that it's going to be 5 pi over 4, which is 1 pi over 4 past a semicircle. Okay, and then finally we're back to radians and degrees. Whoops, I breezed over this one, but let's go back to 3 pi over 2 radians. So I want to multiply with my radians on the bottom of this. So I'm going to go and see that my pi's cancel out. Okay, I have 3 times 180 is 540, but now I have to do 540 divided by 2, and I get 270. Okay, this is below the x-axis on the y-axis, so it's one of our major kind of quadrants that we label on the unit circle to begin with. All right, so that was a great review of conversion. Now is the time that we have to think in terms of unit circle. Now, there's nothing preventing you from using the unit circle on your quiz, but you need to really be able to sketch things out and kind of think about where the placement is rather quickly on your unit circle. Okay, so if I'm looking at 3 pi over 4 and I draw my unit circle, okay, I know that pi over 4 is in the first quadrant, 2 pi over 4 reduces to pi over 2, and 3 pi over 4 is in the second quadrant, and that's what I want. Okay, when I think about cosine, cosine deals with the x value from the origin, but I know that anything with pi over 4, the cosine and the sine are essentially the same, but I have to think about, is it negative or positive? Well, for the cosine in this case, I'm traveling back from the origin in the x direction, so that's the negative direction. So in this case, we have negative cosine, positive sine in the second quadrant. So I have negative root 2 over 2 is going to be the cosine. What is the sine? It would be positive root 2 over 2. So I love pi over 4 increments. Okay, now I'm going to go to my next one, which is tangent. Okay, so right away we know that tangent, to find tangent, what do we need? We need to take whatever the sine of the angle is, and we need to divide it by the cosine of that same angle. So first, when I set up my unit circle, okay, I'm going to think about my pi over 3's, but for me to think about my pi over 3's, a lot of times I go back to my pi over 6's. So my pi over 6's, this is 1 pi over 6. So then this is 2 pi over 6, which reduces to pi over 3. I always use my axes, so this is 3 pi over 6, which is pi over 2. This is 4 pi over 6, which is 2 pi over 3. This is 5 pi over 6, which does not reduce. This is pi, which is 6 pi over 6. Then I have 7 pi over 6. And then I have my 8 pi over 6, which divide both by 2. I get my 4 pi over 3. So this is where I want to be. Okay, so now I'm thinking of the long and the short, because we're using 30, 60, 90 special triangles. So to get to 4 pi over 3, I'm going short, then long. Okay, so when I look at the x value, that relates to cosine. The smaller of the two numbers is 1/2, but because I'm in the third quadrant, both the cosine and sine will be negative. The long that we memorize is root 3 over 2. Okay, so now I'm not done, because I need to take my sine, which is negative root 3 over 2, and I need to divide it by negative 1/2. Okay, but how do we divide fractions? We flip and multiply by the reciprocal, which is negative 2 over 1. Well, I like that because my 2's cancel out. So I have negative root 3 times negative 1. So what's negative times negative? It's a positive. So root 3 is the tangent. Okay, now go ahead and go to your calculator though, and go to your mode and make sure that you are in radian mode, and go ahead and click tangent of, and in parentheses 4 pi, close the parentheses, divided by 3, and close your parenthesis again, and you're going to get approximately 1.73. Okay, but notice the instructions say that I want the exact value. Okay, the decimal is not an exact value no matter how many decimal places you give me. But why am I talking about this right now? Because now go ahead and type in root 3 to your calculator. What do you get? Whoops, you get 1.73. So that's just a way to check, to use your calculator to check, but you can't rely on your calculator for the whole test. Okay, now, so that I don't bore you, I see that this next one is 11 pi over 6. Well, where's 12 pi over 6? What is 12 pi over 6? 12 divided by 6 is 2. So 12 pi over 6 is actually a full lap around the unit circle. So where's 11 pi over 6 going to be? It is going to be the final small slice of pizza before we get back to the beginning. Okay, so there's shortcuts that we can use rather than always counting around the entire unit circle. So if I want the sine, I'm thinking about the y value. So to get to 11 pi over 6, I'm going long in the x direction but short in the y direction. So I know that the short value of my 30, 60, 90 triangle is 1/2. So that's what I want because it's related to the y direction. But when we're in the fourth quadrant, all of the sine values are below the x-axis, so we have to put a negative on there. This one's nice because if you do sine of 11 pi over 6 correctly on your calculator, it's going to give you negative 0.5. And that is an exact answer. Okay, so you would get lucky on that one if you relied on a calculator. Okay, now we are at sine of 3 pi over 4. Well, I already went over that on A as to where that is on the unit circle. So if I draw my unit circle and I just jump right to knowing, that was a bad circle, and I jump right to knowing that this is 3 pi over 4. Okay, if I want the sine, yes, I know they're both root 2 over 2, but in the second quadrant here, the sign is positive. So root 2 over 2 is going to be your answer for this one, and that is positive. Okay, so there are your 4 problems worked out for number 2. All right, now on number, was that number 2? Sorry, that was number 3. All right, on number 4, we are going to find the exact value for each trig expression. So we're pretty much doing the same thing, but then if you notice on C and D, we want to know what angle measure is going to produce the given tangent. Okay, now again, I already went over this on the last page, but just as a reference guide here, we want to remember that tangent of an angle called theta is equal to taking the sine of that angle and dividing it by the cosine of that angle. Okay? I don't know why it got so big there. So, applying that, we again need to look at our unit circle and we need to recall, where is 5 pi over 4? Okay, well, I know 4 pi over 4 reduces to pi, so I can just right away go to my semicircle to know that's 4 pi over 4. And so 5 pi over 4 is going to be in the middle of the third quadrant. So what is the sign going to be? It's going to be negative root 2 over 2. And then what is the sign going to be? Negative root 2 over 2. So the cosine and the sine are identical, and they're both negative because we're in the third quadrant. So to find the tangent, we have to take the sine, so negative root 2 over 2, and divide it by the cosine, which is negative root 2 over 2. Well, instead of doing the fancy multiply by the reciprocal, what's any value divided by itself? That is going to be 1, because a negative divided by a negative makes a positive as well. Okay, so don't get too far ahead of yourself. Now, if you type into your calculator tangent of 5 pi over 4, it's going to give you 1. So please learn how to use that to your advantage as well. Okay, now this was one that I think some of you guys missed on a prior worksheet, so please pay close attention. Okay, we can see on this problem that 17 pi over 6 is beyond 12 pi over 6. And what is 12 pi over 6? That's one lap around the unit circle. That's 2 pi. So if I think about 17 pi over 6 and I subtract 12 pi over 6, which is one lap around the circle, okay, I'm left with 5 pi over 6. And so what this is saying is that the trig values of 17 pi over 6 are going to be equivalent to 5 pi over 6 because you're going to be in the same exact place on the unit circle, okay? Because if I did a lap around, I'll get a different color, okay? Watch my color. This is 12 pi over 6, 13 pi over 6, 14 pi, 15 pi over 6, 16 pi over 6, 17 pi over 6 is right here. Okay, so we are thinking really about our knowledge of 5 pi over 6. So in order to get to 5 pi over 6, we're going to go long, then short. So my cosine is going to be negative root 3 over 2, and my sine is positive 1/2. So I'm going to use these to find the tangent. So I'm going to take 1/2, and I'm going to go ahead and skip ahead and say times negative 2 over root 3. I'm multiplying by the reciprocal. I'm skipping that first step of writing out the division. Okay, so now when I do this, I'm going to not cross out my negative. I don't want to forget about it, but my 2's cross out. So I have negative 1 over root 3. But we said that's not an acceptable answer. We need to rationalize our denominator by always just multiplying by the root that is in the denominator over itself. So when I multiply by root 3 times root 3 in the denominator, I get 3. And then negative 1 times root 3 is negative root 3. Now this does not reduce because you cannot reduce something under the root with something out of the root. So that is the tangent. So this is one where you can't rely on your calculator because your calculator is going to give you a decimal. Now you can check your answer, but when it asks for exact, you are expected to write it in terms of the root. Okay, so now on problem C and D, these problems are saying, think about your unit circle. One lap, okay? That's what this fancy notation right here means. When you see assume that theta is between 0 and 2 pi, that means don't give me an answer such as 17 pi over 6 because that's beyond 2 pi. So when we're thinking about the tangent of an angle being 1, okay, automatically this is referencing that you know that the sine of theta must equal the cosine of theta because that's the only way to divide two things and get 1. So where is the sine of theta equal to the cosine of theta? It's going to be in the first quadrant at pi over 4, root 2 over 2, root 2 over 2. And in the third quadrant at 5 pi over 4, because both are negative, so the negatives will cancel out. So half of you guys may give me this answer, and the other half may give me this answer. Okay? Either one works. In fact, they're both 100% correct. Okay? So if you want to give me both, that would actually be ideal. Now, on this final question, it says the tangent is -1. So that means that it must be the same value, but opposite. So we're still thinking about those pi over 4s, but now we're going to be in the second quadrant, which is 3 pi over 4, and the fourth quadrant, which is 7 pi over 4, because we're almost to 8 pi over 4. In these cases, we have one positive, one negative, and the vice versa is true in quadrant 2, negative, positive. So if I take the same thing divided by the opposite, you're going to get -1. So theta could be 3 pi over 4 to make that true, or 7 pi over 4 to make that true. Okay, either one is going to work. So hopefully that maybe makes you feel a little more comfortable, maybe hearing me go through a few problems. Please make sure that all of this has soaked in before you jump into taking the quiz, because then after the quiz, you're going to dive into a full chapter review. Again, please contact me if you're having trouble. Try to stay kind of on the suggested timeline so that you can progress through the lesson, but keep up the good work and good luck on your quiz.